In this video, I'll be working through this piecewise function worksheet. It's posted in Canvas. It's just called, I think it's called More Piecewise Function Practice. So several people have requested they need more practice, so here it is. So I'm just going to run through it, and hopefully this will help you gain a better understanding of how to graph and write piecewise functions and how to evaluate them. So we'll answer the question whether it's a function or not later after we've graphed it, I think. But first of all, we can answer this question. This says f of 3 equals what? So I check out 3. I know 3 is bigger than -2, so that means I'm going to be using that expression right there. So f of 3 is going to be 9 plus 6 plus 3, which would be 18. And then this says what's f of -4? Well, that means -4 is less than -2, so that means I want to use this one. So that would be -4 plus 5, that would be equal to 1. And then finally f of -2. Well, -2 is right on the borderline, but this says use it down here. So that would be 4 minus 4 plus 3, which of course would just be 3. Okay, so my battery just died, so I had to plug it back in. So here we go again. So we were just about ready to graph this piecewise function. I'm going to clean that up a little bit. So when I'm graphing a piecewise function, I like to put a dividing line in. And so the dividing line, of course, is at -2, because that's where the domain switches. And I think it's helpful. Whoops. How did you do that? This guy. There we go. So we have two domains that are being dealt with. Yellow is defined this, or Y is defined like that in the yellow, and it's defined by x squared plus 2x plus 3 in the blue. So this helps us to see how these things, it gives a visual picture of where to change, okay? So in the first one, x plus 5, that's just a line that crosses up 5. I could go up here to 1, 2, 3, 4, 5, and then just work backwards. Down 1, and then hit a dot there. Or I could just plug in -2 for x. -2 plus 5 is 3. So I notice that puts me right at 3. And it's just a linear equation with slope of 1, so I'm from there just going to go like this. Okay, that's the one side. Now the other side is a parabola. Now the nice thing about this is the y-axis is in the blue, and we know how to graph parabolas, right? So you could get you could find the x-coordinate of the vertex by going -b over 2a. That'd be -2 over 2, which would be -1. So we know the vertex is at -1, comma something. If I plug a -1 in there, that's going to be what? 1 minus 2 is -1, plus 3 is 2. So the vertex is at -1, 2. So that's my vertex. And this is a normal shaped parabola because the stretch factor is 1. So I know it's going to look something like this. 2 up 1, 2, 3. And it actually fills in that dot, doesn't it? So now when they ask for the domain, well, clearly the domain is all real numbers, and you can just write that as a double backed R. And the range is also all real numbers, because it's going forever down here and forever up there. Okay, so we're going to, I'm going to try to move through this fairly quickly. So this one, the dividing line is at 1, so I'll put a little dotted line down there, and I think I'll grab my changing sides this time. I don't know why, but I just am. So we got the yellow side and the blue side, but they've been switched. This time that's yellow and that's blue. So to graph in the blue area, That's a linear equation that crosses the line at 1, x, or the y-axis at 1, and has a slope of 2. So since the y-axis is in the blue area, I can go right there and put a little dot at the y-intercept, go over 1 up 2, and put another dot, because it's greater than or equal to 1, a solid dot that is, and then I would just draw it like that. And then on the other side, I have a parabola, which I don't know, it's not in the y-axis, but I mean the y-axis is not in there, in the yellow area, but I could just go to 1, plug in 1 in there and see what I get. When I plug in 1, I get 4, so at 1 it should be at 4. I'm going to put an open circle. Oh, that was a really big open circle. Open circle. And then I could plug in another point to get, like for example, I could plug in 2 and see what's happening. 2 squared is 4, 4 plus 3 is 7. So at 2, I go 1, 2, 3, 4, 5, 6, 7. So I can see that it's, whoops, sorry. It's going something like, now it's not a straight line, it's a curved line because it's a parabola. But we can't really see enough of it to see how it's curving. But you can tell it's going to curve. It's going to probably come down right about there and go back up. So you get the picture of what it looks like. Okay. And we could plug in these numbers real quick. F of -2. Well, at f of -2, it's down here at -3, isn't it? You would find that also by putting in -2 up here. -4 plus 1 is -3. F of 6, that would mean use this one. 6 squared is 36, that'd be plus 3 is 39. And f of 1, that would be using the top one, so that would be 3. And the domain is, again, all real numbers, and the range is not all real numbers. The range goes from -infinity to 3, including 3, and then starting at 4, but not including 4, and going to infinity. Okay? So here's another one. We got a dividing line at 2. So put a little dot, dotted line I mean, and yellow's back on the left again. Blue's on the right. So that's blue and that's yellow. So in the yellow, we're using the line y equals -2x plus 1. So I would cross the y-axis at 1 and goes over 1 up 2, over 1 up 2. And I'm going to put a solid dot because it's less than or equal to. And that's my yellow side. Then on the blue side, I'm using another. It's a linear equation with a slope of 5 and a y-intercept of -4, but the y-axis is not in the blue. So I'll just plug 2 in there. 2 times 5 is 10. 10 minus 4 is 6. So when x is equal to 2, I should be up here at 1, 2, 3, 4, 5, 6. I'm going to put an open circle there. And the slope is supposed to be 5, so it's going to shoot up really steep. And it goes off the charts there. So f of -4, that would be in that first one, so that'd be 8 plus 1 is 9. So if I plug an 8 in there, that means I'd be using the blue one. So 5 times 8 is 40. 40 minus 4 is 36. And 2 would mean I'd be using the yellow one because this is less, that's for x less than or equal to 2. So I plug 2 in there, it'd be -4 plus 1, which would be -3. And again, look at over here, the domain is all real numbers because the left and right are all covered. The range is going to go from -infinity to 1, 2, 3, 4, 5, and that would be a hard bracket. And then from 6, soft bracket, to positive infinity. Okay, and oh, here's a fun one. We got 3 pieces, so we got a dividing line at 0, another one at 5. 1, 2, 3, 4, 5. So we're going to bring in 3 highlight colors. So blue is going to be the first one to the left of 0. Yellow will be the next one between 0 and 5. And then we'll get this, is that a purple? What is that? Yeah, it's kind of a purple, I guess. So we have 3 different zones, so to speak. Let's fill in some values here. F of -2, that would mean I'm using x is less than 0, so I put it in there. That'd be 4 minus 1 is 3. F of 0, that would still be in that category, so that'd be -1. And f of 5, that would be right in the middle one, so that'd be 2 times 5 is 10, minus 1 is 9. Okay, so now we're going to graph. In the blue area, it's supposed to be a parabola, x squared minus 1. So if I plug a 0 in there, I start at -1, so I know that I'm going to have a dot right there. And it's a dot because it says x is less than or equal to 0. And then from there, if I check another one like -1, if you plug -1 in there, you can tell that's going to be 0. But I'm not surprised because I know that first dot was the vertex. So this is the normal shaped parabola, goes over 1, up 1, over 2, up 1, 2, 3, 4, etc. So it's going to be a curvy thing like this. So that's the first part, the blue part. The yellow part is a line, y-intercept at 1, or -1 I mean. So it actually, even though it's not included here, it's gonna, there's already a dot there, so it's gonna start at that same place, right? And it's gonna go over 1, up 2, 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 and it's gonna be off the charts. Whoops, I missed. And this will be solid also. And then finally, the last one, it says when x is bigger than 5, then the y is just 3. So I go 1, 2, 3. I'm going to put an open circle right there, and then just nice straight line. Here, once again, the domain is all real numbers because we had everything accounted for right here, right? The range is going to, the lowest you can get in the range is -1. And it looks like the highest you can get is, well, there's no limit because this goes forever up on this side. So that would be positive infinity. Okay. Let's see how many more of these. Okay, I think I'll do these 5 and 6 offline, and I'll post this solution sheet also along with the video. And let me do a couple of these. Write equations for the piecewise functions whose graphs are shown below. So maybe I'll grab number 9. That's a complicated one. So once again, I need to write my f of x. And I'm going to have 3 parts here, right? So it'll look like this. The first part is this one here, and that's just a line. Has a slope. Can you tell what the slope is? Well, that's hard to tell, isn't it? It looks like it's slope of 1. Maybe they just got off down here. Doggone it. We're going to say it's a slope of 1, even though it missed a little bit down there, but it looks like it's going down over 1 down. 1 over 1, 1. See, it misses right there. Yeah. We'll call it a slope of 1, even though I think it's a little bit off. And notice that if it kept going, it'd cross right there, wouldn't it? So this is going to be x plus 2 would be the equation for that first one. The next one is going to be a slope of 1 also, but across the y-axis at 1, 2, 3. So that'd be x plus 3. And then this third one is a line with a slope of 1, so that's going to be x plus something. And notice if you continue this down, it'd hit the y-axis at 1, so that'd be x plus 1. So we have 3 linear equations, all with a slope of 1. And they all have different y-intercepts. So then we put over here to the side, how do you describe each one of those lines? Well, I mean, how do you describe the domain of each one of those lines? So in other words, I'm using this line from -infinity. So I'm going to put over here from -infinity. It's an ugly infinity. -infinity. All the way up to and including -1. And then I start just after -1 and go till +1, but neither one of those are included because we got open circles there. Then the final domain is going to be from 1 to positive infinity. Okay? This one here, similar, is going to be 3. So I'm going to do f of x equals, and it looks like the first one, oh, I didn't leave myself enough room there. I'm going to move that over a little bit, sorry. Let's go over here, f of x equals. So there's my dividing zones right there. The middle one, 1, 2, 3, 4. 1, 2, 3, 4. The middle one's just 4. That one's pretty easy. This side one is a line again. Can you see what the slope is? Looks like it's going over 1 up 3. Over 1 up 3. Yeah, that hits. So that's going to be 3x plus something. And if I keep going, right now I'm at 1, 2, 3, 4. So over 1 would take me up to 7. And then over another one would take me up to 10. So that's going to be 3x plus 10. And then this one over here looks like it's going down the same way that's going up. So this is going to be a negative 3x. And again, I think if you go over 1 up 3, you're going to hit 10 up there also. So that's the definition, the function definition on those intervals. Now we just got to describe the intervals or the domains. So this is going to go from negative infinity till looks like negative 2. And now as far as where what goes hard and soft, it doesn't really matter because these guys end and begin at the same place. So I'm going to just call this soft, and then I'll say this is from negative 2 to 2, and give them both hard brackets on either end. Then this will be soft, and it'll be 2 to infinity. Now again, you could have called this one here a hard bracket and that one soft. It doesn't really matter because again, these guys begin and end at the same place. If I plug in negative 2 in there, I get 4, and of course I get 4 there. And if I not plug positive 2 in there, I get 4. So they give you the same result. So here's a kind of a fun one, number 11. So f of x is equal to, and there's going to be 3 things, but they're pretty easy. The first one is just 1, the second one is just 3, and the third one is 1, 2, 3, 4, 5. So it's pretty easy to tell what the y value is. And so, but then we just got to fill in the domain. So now the domain here is going to go from 0 to 2, but not including 2. The domain for the second one is going to go from 2 to 4, but not including 4. And then the third one is going to go from 4 to 6, but not including 6. That's pretty fun. You could also probably come up with this graph with the greatest integer function, if you remember, which is one of the parent functions you'll learn about. But anyway, that's the way you do it with Piecewise. Okay, so I'm going to end this video, and then I'll finish the rest of this worksheet, and I'll post both the video and the worksheet, and the solutions worksheet.